outsiders enslaving us while they pass through. Neil deGrasse Tyson exclaims, confirming the most puzzling and regrettable revelation made by the explorer during the preceding 10 years. A revelation for which scientists were not prepared in the slightest. Everyone is under a strained atmosphere, and the scholarly community has not been able to get any rest since the explorer returned this disturbing information from orbit. The explorer recently identified these mysterious things. Thus, analysts, researchers, and engineers have been hurried from their positions to take on these items. We cannot dispute that we have never seen anything like these strange things before, even though we have no idea where they are coming from or heading. What are these mysterious objects that Explorer 1 recently discovered? Come along today as we dissect these responses in Neil deGrasse Tyson's Explorer 1, which has located 500 enigmatic space objects. Explorer 1 has been traveling the space highways for almost 50 years, exploring deep space that has been off-limits to ground-based observatories and making jaw-dropping discoveries that leave us speechless. The Johns Hopkins Applied Physics Laboratory is home to virtuoso personalities who flood in, and Explorer 1 has been the shining core to the uncharted realm of interstellar space. Our eyes have been awakened to the astounding wonders of our cosmos by this technical marvel. Neil deGrasse Tyson has confirmed that Explorer has found 500 strange objects that are peacefully coasting across space. As conventional researchers started poring over the data they had gotten from Explorer 1, they were shaken by this news. Not too far away, something strange was stirring, and it was difficult to solve this nagging mystery that had stumped the greatest of investigators. Ever since Neil deGrasse Tyson confirmed this revelation, other interpretations have been floating about, each attempting to paint a different picture that helps explain the riddle. Researchers may have doubted the veracity of the data if a different spacecraft had transmitted the kind of confusing data that has recently been transmitted from space. But in this case, we are talking about Explorer 1, the space probe that has exceeded our expectations and has been traveling through space's highways for almost 50 years. Similar to a patient who overcomes illness, Explorer 1 has outlived the 3-year extension given to its life by spending more than 45 years in orbit and making groundbreaking discoveries during that time. The most endearing aspect of this noteworthy narrative is that Explorer is writing this account of triumphing over misfortune from a very remote location on Earth. As of the last time scientists checked, the spacecraft was traveling at a speed of 14.5 billion miles per hour, far from Earth, and showing no signs of slowing down anytime soon. According to experts, the spacecraft has been orbiting the Sun at a speed that is several times faster than Earth-Sun distance annually. Given the length of the space probe's voyage, one would have thought that its speed would have drastically decreased. Thus, researchers are finding this one difficult to stomach. Upon closer inspection, it seems that Explorer 1 is destined to be the exception in this tale, and its most recent discoveries have provided further evidence of this. When Explorer 1 slapped researchers with energizing news that would linger in their memories for a long time, it was simply another ordinary day for them. In orbit, Explorer 1 had noticed several mysterious objects. Because of this spontaneous disclosure, cosmologists were initially perplexed when they examined data indicating that about 500 opaque objects had suddenly materialized out of nowhere. For a brief while, we had very little information about the existence of these things. Then, scientists were working non-stop to solve the mystery that nature had placed at their feet. Researchers found themselves in a bind, and there was only one responsible party: Explorer 1. In a paradoxical way, scientists also understood that the space probe had much of the responsibility for solving this puzzle. When this discovery first became public, some scientists wondered if there was a chance it was an error. They believed that Explorer 1 might have found it at first, and that as a result, it might have sent us inaccurate information. If we decide to continue along this unfolding route, it makes sense as an explanation, considering that Explorer 1 was launched as far back as 1977. After over half a century of continuous service to humanity, one can expect the computers and the space equipment to have grown weary and started to malfunction, reducing their functionality and returning low-quality data to the ground team. Even while this tale seems compelling, scientists have warned against stopping there because doing so would be disrespectful to the explorer's selfless sacrifice. In defiance of the hurried assumptions of skeptics, Explorer 1 has continuously delivered insightful data about our cosmos despite the harshness and unstable environment of space. The space probe's 2 backup computer systems have allowed it to survive a long time. Altitude and Attitude Control Systems, ACS, and Flight Data Systems, FDS, were the 2 sets of command subsystems that accompanied Voyager 1, its twin. This has been the hidden force that has allowed space travel and discovery-making to proceed with a strong sense of resolve. The explicit redundancy allowed for consistent system modifications and the capacity to wake up computer components that had been inactive, prolonging their lifespan. The experts back on Earth devised a scheme to help the space probe increase efficiency while they were designing Explorer 1. This implied that the instruments on the probe would have to rely on logic that was constructed. Given their limited resources in terms of both time and money, they were not taking any chances in this area. The electrical experts concluded that hardware logic-based, streamlined systems would have to be used in the development of the instruments. As a result, 3 dual redundancy pairs and 6 onboard computers were integrated into Explorer's computer systems to form a dispersed system. After overcoming this barrier, the researchers had to face up to the next big impediment in the form of system maintenance. The creation of a continuous power management plan allowed for the victory over this difficult task. This is where things start to get interesting. Power management entailed maintaining Voyager's computer system's working capacity. To put it simply, with the restricted power resources on board the space probe, this is a difficult assignment to manage. It was an example of using a small set of gear to send a tracker into a remote wilderness to pursue untamed animals. Through the development of strategies to improve and preserve power on board the Explorer, researchers were able to get around this problem. One practical illustration of the power management strategies developed by engineers is the selective shutdown of non-essential systems. Experts had to make this difficult choice, so they used a methodical technique to find and disable components or subsystems that weren't necessary for the space probe to accomplish its primary mission objectives. A cursory look of heaters connected to certain equipment that had to be turned off provides evidence of this. Originally, the purpose of these heaters was to maintain a certain temperature for the instruments in order to ensure optimal performance. The narrative had to be changed, though, because turning them off drastically decreased the Explorer's power usage. The Explorer's life expectancy will increase as a result of this decrease in the power consumption of the space apparatus. Everyone benefits from this agreement, both parties to it. Furthermore, it's important to keep in mind that shutting down non-essential systems is not a decision that is made lightly. It is a planned move that necessitates a careful evaluation of the trade-offs between power saving and the space probe's scientific goals. Every time a choice of this nature was made, all hands had to be in the air. It was necessary for researchers and engineers to get together and evaluate how turning off particular systems might affect the availability and caliber of scientific data. This was based on the facts at hand. Feelings had no bearing on anything. The team's motivation stemmed from the aim to increase power economy without sacrificing the spacecraft's fundamental capabilities, allowing it to continue collecting important data about the cosmos. Engineers and scientists alike were unfazed and thought that nothing could stop Explorer from uncovering the profound truths that are concealed in the shadowy reaches of space, secrets that the cosmos has been keeping from us for a very long time. But there are other ways NASA engineers are ensuring the Explorer survives and functions as best it can in orbit besides targeted power reduction. For the good of the spacecraft and researchers, they still had one more hidden weapon up their sleeves that they needed to use. The constantly shifting conditions of the shuttle's environment required the engineers to devise power management plans. For example, the amount of solar energy accessible to Explorer 1 decreases as it travels farther from the Sun. While we acknowledge that this is a problem, the engineers were ready. They made sure the spacecraft changed its power consumption to account for this growing hazard. The flexible strategy ensures that the power resources are deployed effectively to support the probe's vital operations and data transmission back to Earth, which is a win for NASA engineers and researchers. Strangely, the good news doesn't stop here. Over time, experts have been able to hone and enhance the spacecraft's power systems thanks to continuous technological breakthroughs and improvements in power management. Upon closer inspection, these enhancements include better battery charging methods, more effective power distribution, and advances in power management and control. For engineers, the adoption of deliberate and well-planned power management protocols has created an intriguing new opportunity. It has allowed experts to prolong the Explorer 1 spacecraft's operational lifetime in conjunction with Voyager 2's. For both the academic community and the general public, this is a significant win. The methodical distribution and administration of power resources have given Voyager 1 the necessary strength to carry on delving farther into the cosmos. The revelation sent shockwaves across the scientific research halls. 10 years of painstaking exploration by Explorer 1 across the enormous area of interstellar space were punctuated by Neil deGrasse Tyson's dreadful proclamation, which reverberated around the world. By happenstance, the rocket had discovered a peculiarity of great significance: 500 perplexing components that started and had motives that are shrouded in intense mystery, moving silently through space. Within the research community, this unanticipated experience set off a chain reaction of events that resulted in sleepless nights and general tension as analysts, engineers, and academics tried to piece together the ramifications of Explorer's disclosure. An emblem of human resourcefulness and drive, Explorer 1 had stunned everyone by cruising well beyond its extended life expectancy to become a beacon of exploration in the depths of space, defying a world where the known laws of physics appeared to waver. Its instruments sent data that defied common wisdom, having been painstakingly built to withstand the rigors of space travel. The hopes and concerns of those confined to Earth traveled with the rocket as it resumed its lonesome journey through unfamiliar realms. Every data transfer and signal received revealed previously undiscovered facets of the universe's complexity, challenging preconceived notions and encouraging humanity to reconsider its place in the universe. Following the disruptive disclosure of Explorer 1, scholastic circles were rife with theories and heated debates. Was this a fortuitous meeting with extraterrestrial intelligence, or was it a window into hitherto unseen events of enormous proportions? The unresolved issues spurred an incessant pursuit of understanding as scientists analyzed data streams and scrutinized telemetry reports in search of elusive indicators. Notwithstanding the doubts, one thing was certain: Explorer 1 had fundamentally changed our perception of the cosmos, pushing the bounds of discovery and motivating future generations to pursue the quest for knowledge beyond the stars. The scientific world was shaken by the urgent voice of Neil deGrasse Tyson, which signaled potentially damaging news. In deep space, Explorer 1 had unintentionally discovered a puzzle. 500 unknown materials silently drifted across the measured emptiness, defying all known arrangements. Scientists and engineers alike were gripped by a frenzy that spurred them to action. These peculiar objects, unlike anything previously encountered, characterized Explorer 1, our courageous explorer who spent over half a century in space. It carried on traveling, stretching boundaries, and revising the guidelines for interstellar travel. Scholars grappled with the consequences, realizing that Explorer 1's role as a universe guardian was far from ended. Its discoveries kept surprising and perplexing people in equal measure.